So section 2.3 is about solving absolute value inequalities. I've abbreviated absolute and value just as abs-val. So very much the same idea as the previous section, but because we're dealing with an inequality instead of an equation, there's a few modifications we need to make. But the overall process is going to feel rather familiar. First step is to isolate the absolute value on one side of the equation, just like we did previously. The next step is to split that absolute value inequality into two linear inequalities. I'm going to put a little star there because there's a little bit of a difference there when it comes to doing that splitting in the inequality sense than there was in the equation sense. The third is to solve each inequality And now for these absolute value inequalities, we're not going to be graphing. We're not going to be checking. Rather, we're going to graph our solutions on a number line to determine the type of inequality our answer is, whether it's an and inequality or if it's an or inequality. And we'll see a little bit more of what I mean by that when we get to an example here. Everybody so far so good? So let's say we have the absolute value of x minus 2 minus 3 is less than 1. If I'd like to isolate my absolute value, my first step should be to add 3 to both sides. That's correct. What now? Good, so we've isolated the absolute value, so we can split this now into two equations, or I should say two inequalities. And this is going to be a little bit different, just minorly, but a little bit different than what we did before. So the first inequality is easy. It's the exact same thing as we have, just without the absolute value. For the second inequality, just like before, we drop the absolute value and we negate the right-hand side, but we also flip the inequality symbol. That is a place where many students forget. So always in that second equation, we're going to flip that inequality symbol. Everybody okay with that idea? Okay. So we can continue on solving. So here we'll add 2 to both sides. And likewise, we'll add 2 to both sides there. Everybody okay with that? And now we just need to check. So to do that, we're going to graph this on a number line. So I'm going to graph both inequalities on the same number line. So I'm going to start by graphing x is less than 6. So I would start graphing that by making a mark at 6. Should I make a filled-in circle or an open circle at 6? Open. Why should it be open? Good, because it's a strict less than inequality. It's not nor equal to. Yes, Sierra?
If it's greater or less than, is always
correct. And then which way should my arrow be pointing? To the left or to the right? To the left, because that's where the things that are less than 6 live on my number line. Only if the variable's on the left-hand side. If you've written the variable on the right-hand side, then no. So it depends on where the variable is for that to be true. Yes, Jeff? Of course. Now let's graph the other inequality. So here we have x is greater than negative 2. So I'll start by making a mark at negative 2. What kind of mark should I make? Open. Why is it open? Because there's not an or equal to. The or equal to's are the closed ones. And which way should the arrow be pointing, left or right? To the right, because that's where the things greater than negative 2 live. You see how these two arrows are pointing at each other? This means and. So my answer would be x is less than 6 and x is greater than negative 2. You can write it this way, but if you were taking a standardized test, they would likely write this as the compound inequality. Negative 2 is less than x is less than 6. I would accept either version. But if you are taking an ACT or some other kind of standardized test, it's unlikely they would write this with the word and. They'd rather write this as the compound inequality that I've described over here. So what is this solution set saying? What it says is if I pick any value between negative 2 and 6, that should satisfy my inequality. Anything else should not. Okay with that idea? So just as an aside to demonstrate this, let's pick a value in between negative 2 and positive 6 and just kind of confirm for ourselves that when we do this, the inequality is satisfied. It is. I'm not actually requiring you to do this. All I'm trying to do is show you what this solution set is saying. Like, what does this answer mean? Okay? So if I plug 0 in, which I've picked out of this range, when I evaluate this, when I plug it back in, I get negative 1 is less than 1. That's correct, right? Negative 1 is less than 1. If I picked something else that was outside of the range, say 7, and I try to do the same thing, I get 2 is less than 1, and that is not correct. Everybody okay with that? So what my answer is doing is describing all of the x's that satisfy this inequality. So they have to be between this value and that value. In this case, negative 2 and positive 6. Is everyone okay with that? Let's do another. So what should I do first for this? Minus 2 from both sides is correct. So when I do that, I get 3 times absolute value. X minus 7 greater than or equal to 9. Now what? Divide by 3 is correct. Only if that 3 is a negative does the inequality symbol flip, and only during multiplication or division. When we multiply or divide both sides of an inequality by a negative, our inequality symbol would flip directions. Otherwise, it would remain the same. Everybody happy to hear? What now? Negative. Yep. Good. Everybody happy with that? I agree. And so to solve, I'll just add 7 to both sides. And let's graph. So, x is greater than or equal to 10. The mark I make at 10 is filled in. And which direction? Left. I said 10, but that's okay. 10 is to the right. But 4 is filled in and to the left. That is correct. We just misunderstood each other, I think, there. Okay. Notice here, the arrows are pointing away from each other. This situation is the or. So my final answer should be this. If you don't remember to put the and and the or in, I will mark down for that. So the and or the or needs to be there. Is everybody okay with that? So what this one is saying is if I pick something less than 4, my answer should work. If I pick something bigger than 10, my answer should work. If I pick something from this between 4 and 10, though, that answer will not work. Those will work because they are included. Sierra. So if I want the x's that are bigger than 10, that's things like 11, 12, 13. That's all over here. So I just think strictly about the definition. Like, give me an example of something bigger than 10, 11. That way. That's the way I think about it. I don't like to try to play the if the inequality symbol is pointing in this direction, it goes, just use your common sense. It's easy to do with common sense. I prefer to do that than try to make up, some esoteric rule that might be wrong if I instead had written the variable on the right-hand side instead of the left-hand side. So I try to stay away from that kind of stuff. Okay. As an aside, am I going to get answers that look like this, where both arrows point in the same direction?
No, you're not.
If you get an answer that looks like this, you've made a mistake somewhere. This won't happen. What is the likely place that you've made your mistake?
The symbols. Oh, not flipping the symbols.
It's probably forgetting to do this. Well, you'd end up flipping both times, so you would end up, the same thing would happen. They should still be pointing in either opposite directions, but not ever like this. Yep, it would change to positive just like it did for the equation ones. Of course. So let's do one more here. And this will, of course you can. All right, this is probably about as hard as I can make it. What should I do first here? All right, subtract 10 from both sides. Okay, then what? Good. Divide by -2. What do I have to remember here, though? I have to flip the inequality symbol. Why am I doing that? Because I'm dividing by a negative. Okay. Everybody happy with that? Okay, what should I do next? Yep, I split it up. The first one is 4x minus 7 is greater than 2. What's the second one? Huh? I think you're looking at an inequality symbol. Oh, excuse me. My apologies. I didn't mean to say 7. I meant to say whatever it's supposed to be when I said 7. Yeah. What should my second equation or inequality be? To -2. Okay. All right. So let's solve that first inequality now. What should I do first? Do I have to flip when I do this? No. Not for addition and subtraction do I need to do any flipping. Now what? Now we have to divide by -1, or you could think about it as multiplying by -1. Either is fine, but when we do that, what do we have to remember? Flip the sign. So how many of you guys think you would have made a mistake on some sign flipping at one point here? We've done a lot of sign flipping here. This is about as hard as I can make it. It's just like flipping these things back and forth. Jack's like, I got this, no biggie. So same idea on the other side. But this is why we practice some of the tricky ones here, is to get us ready for, a test or a quiz where we might have to do something similarly, detailed. Everybody happy with that? Note that I flipped the sign there on that one when I divide by the negative. So, to do my check, 2, 3, 4, 5, 6. So filled in at 2. Less than 2 is over here. Greater than 6 is over there. This is an OR. So notice I had to flip this inequality twice and this one 3 times. Ay, ay, ay. Okay with that? I'd like to return now to some more examples of solving absolute value equations. I want to backtrack to this because there's a situation that can occur that we haven't talked about yet that is a little bit tricky. So we've backtracked to solving. So let's say I want to solve absolute value of 2x plus 12 equal to 4x. What's different about this example than the things you did last night in your homework? Yeah, I have x's outside the absolute value as well as inside the absolute value. Everybody can see that? A little bit different than anything you saw in last night's homework, Christina? Of course. We will solve it the same way. So nothing new really happens here. So notice that my absolute value is already isolated. So I can immediately go into splitting this. Everybody happy with that? Nothing surprising here. So to solve this, what should I do next? Yeah, subtract 2x from both sides will be good. So that's going to give me 12 equals 2x, and 12 equals negative 6x. And then I'll divide both sides by 2, and then divide both sides by negative 6. And then my last step would be to check, right? 6 equals 6. 2 times 6 plus 12 should equal 4 times 6. Well, 2 times 12 is 12. 12 plus 12 is 24. The absolute value 24 is 24. And 4 times 6 is 24. So that's one answer. Everybody agree? Okay. So 2 times negative 2 plus 12 equals 4 times negative 2. 2 times negative 2 is negative 4, plus 12 is plus 12 is positive 8. The absolute value of positive 8 is positive 8. 2 times negative 4 is negative 8. Those don't work. That one is extraneous, and I have just one solution. I don't believe we saw any instances last night in the homework where we got one answer where the absolute value didn't equal 0 at the start. You guys remember that? So this is something that can happen. Worth kind of doing a couple of examples here to make sure we feel okay with this. Let's do another example here. What if, yes, Christian? Yes, of course. So let's say we have the absolute value of 4x minus 1. Minus 1 equals 2x plus 8. Good. First step, we'll add 1 to both sides. Okay. Now what? Split it up. Okay. What should I write for my first equation? Anybody? Good. So it's the same thing without the absolute value. And what should I write for the second one? Good. So Jack says negative 2x minus 9. I would wager that the majority of us would have written negative 2x plus 9. Okay. So when we say make the entire side negative, what we're really saying is this. So we got to make sure we distribute that negative across the entire right-hand side. Well, eventually we want to get into this form here, but I wanted to explain where that form came from. So it wasn't just one of those things like, woo, because eventually you're probably going to look back at your notes, and it helps to kind of include maybe more work than is necessary so that you're reminded, like, oh yeah, that's how we do that. You know what I mean? Okay. So, for 4x minus 1 equals 2x plus 9, what should I do here? Add 1 to both sides, and then what? I would not divide by 2x. I would subtract 2x. So notice what happened is over on the left-hand side, the constants have canceled out. And on the right-hand side, the variables have canceled out. Right? That's my general goal there when having... Correct. So then we divide by 2 and we get x equals 5. How about on the other side? Add 1. And then what? Add 2x. Or reduce negative 4/3. Yep. Depending on the direction of whether I want answers is like fully reduced or not. But if it doesn't say that like we need fully reduced and simplified answers, if you gave me an equivalent answer, I probably wouldn't mark it down. In general, writing this answer in simplest form is best. And we should probably get in the habit of doing that. But depending on the directions on the test, I may or may not be lenient on that, depending on the direction. Yeah, Elise? That's not your name. Alicia. Alyssa. Zita, did you have a question? Oh, go ahead. Okay. Are we done here, though? No. Still got to check. Short of graphing, yes. You could graph this and check also, but sure. Well, the issue with the graphing is you have to, if you're doing it by hand, it has to be really accurate. And if you're doing it on the calculator, you have to be smart enough to pick the appropriate window to where you can see everything you need to. So this is a little bit more idiot-proof than graphing is. I shouldn't say idiot-proof, but like foolproof. Sierra.
Before that, I did the original, like a very, very original equation with plus 8 and not the plus 9. So for the check.
Oh, yeah, I'm sorry. I should have done the -1 and +8 here. Sure. It still comes out to be the same thing. The two sides are equal.
Oh.
So the two sides are still equal, right?
Yeah, I said it.
Yeah, 18 equals 18. Yeah, regardless of what it equals, as long as the two sides are equal, it's fine. Yeah, it's fine. Yes, but you're right. I did look at the wrong step when I pulled that. You are right. Okay. So 4 times -4/3 is -16/3 minus 1 is -19/3. The absolute value is +19/3. 2 times -4/3 is -8/3. Plus 8 is the same thing as +24/3. That gives me 16/3. And then 19/3 minus 3/3 is 16/3. And that does work. I bulldozed through that because you could certainly just type this whole thing in your calculator and see if the two sides are equal, right? So again, if you don't feel great about your mental math with fractions, like literally, I would do 4 times -4 divided by 3, close the parentheses, -1, -1. So that's the whole left-hand side. and then I'll do the whole right-hand side. So 2 times negative 4/3 plus 8. And I got the same thing, so they checked out. Again, I don't need to necessarily see the work for your check, but you do need to make like some kind of note that like, yo, I checked this, and these both worked, or this didn't work. And usually the way that I would just say is that if you put like a check mark next to it and circle it, I'll count that as you showing that you checked it. And an X through it if it didn't work, and just a check mark if it does. Okay? So, Sarah, do you feel okay with that? Just using the calculator to do that sort of thing? Again, it's about, the checking is not about like, can you do like simple arithmetic? It's can you check this to make sure you're getting non-extraneous solutions. And if you need to use your calculator to do that, use your calculator to do that. It's not a big deal. Okay? So, that's going to close this.